Hi, in this video we're going over section 2.2, which is the slope of a line. So when we're looking at a straight line, the slope is talking about the steepness of the line. So whether it's fairly flat or really steep. When we're looking at word problems, we might also refer to the slope as the rate of change. And with a linear function or a linear graph, the rate of change is always the same. So it's what we would say is constant. So it always stays the same. So when we're trying to find this slope, it's actually a number. So we're first going to look at the definition of it and then find the slope using 2 points. We usually refer to the slope using the letter m. You might have also heard of it being referred to as the rise over the run. So the rise is the change in the y values, and the run is the change in the x values. So symbol-wise, the change in y, so the change in something looks like a triangle. So we've got the change in y over the change in x. Or you might have seen the formula y2 minus y1 over x2 minus x1. And again, that's the change in the y values over the change in the x values. Consider the following. Find the slope of the line that goes through the points 3, 6, and 5, 9. That is these 2 points graphically. And graphically I can actually count what's happening with these two. If I'm looking at the rise over the run, then I'm looking at how much the y values change. So it goes from 6 to 9. So that's positive 3 units for the y values. And then I have to go over 2 units because I'm going from 3 to 5. And that's a positive because it's to the right, 2 units for the x values. So you'd have the rise is 3 over the run is 2. And I actually can't simplify that at all. However, if I didn't have a graph and I didn't want to graph it because maybe the numbers are really big or something like that, I can use the y2 minus y1. So in this case, we would have to determine what y2, y1, x2, and x1 are. So that's basically one of the points. So let's say that this one's x1, y1, and this one is x2, comma, y2. So that means my y2 is going to be 9. Oops, I didn't realize that I wrote y2 twice. Minus my y1 was 6, so I have 9 minus 6 over my x2 was 5 and my x1 was 3. 9 minus 6 is 3, 5 minus 3 is 2. So the slope for this line, which we already knew, is 3 over 2. I want to look at a couple kind of weird cases. So let's say that you're asked to find the slope of the line that goes through the points 0, 3 and 0, 10. The x value stays the same. So if the x value is actually staying the same, that means that we're looking at 2 different y values. So maybe one around here where the y value is 3, and then one up here where the y value is 10. And then the x values are all the same. The x values are 0. So this is actually a vertical line. So if I use my formula here, so y2, I have 10, minus y1 is 3, over 0 minus 0. So I end up with 10 minus 3 is 7, over 0. You're actually not allowed to divide by 0. That's what we would call undefined. So vertical lines actually have what's called an undefined slope. Go ahead and look at the other kind of weird case where the y value stays the same. So this problem says find the slope of the line through the points 4, 5, and negative 2, 5. So if we went to look at this one, the y value stays the same. So there's 5. So I have 1, 2, 3, 4, where the x value is 4 and the y value is 5, or when the x value is negative 2 and the y value is 5. So we've got a horizontal line here where the y values are always staying the same. So looking at the slope, we have y2, which is 5, minus y1 is also 5, over x2, which was negative 2, minus x1, which is 4. So I end up with 0 over negative 6. Now, remember that you are not allowed to divide by 0. That's when it's undefined. If you have 0 divided by something, that's actually okay. It's just equal to 0. So if 0 is on the top, it's okay. If 0 is on the bottom, undefined. So here we have a slope of 0. So that means horizontal lines have no slope. So vertical lines have an undefined slope and horizontal lines have no slope, or a slope of 0. What if we don't have a graph to count from one point to the other, or if we don't have 2 points? What if instead what we have is the equation of the line? How do we find the slope of the line with an equation, specifically here, that is 5x minus 2y equals 7? Well, in order to get the slope, we have to first get y by itself. So in order to get y by itself, I want to get this term by itself, so I have to move the 5x to the other side of the equation. So I'm going to have to subtract 5x from both sides. So I have negative 2y equals negative 5x plus 7. And then I need to divide everything by negative 2. So every single part of this is divided by negative 2. So I end up with y equals, and then negative 5 divided by negative 2, well, a negative divided by negative is positive, so 5 halves x, and then positive 7 divided by negative 2 is negative 7 halves. Now this form of an equation is called the slope y-intercept form. So the slope y-intercept form is where y is on one side by itself, you have a number, which is the slope, times x, and then the y-intercept. So here our slope is actually 5 halves, and our y-intercept is actually negative 7 halves. So that's our y-intercept, but we were asked for the slope. So in order to get the slope from an equation, you need to solve for y, which just means get y by itself, and then look for the number that's multiplied by x. Whatever number is multiplied by x is what the slope is. Look at graphing a line given the slope and a point. So I went ahead and actually gave you an equation that's in slope y-intercept form. That means that our slope here is actually negative 1/2 and our y-intercept is 3. So we have a point at 0, 3. Because for the y-intercept, that's where your x value is 0, since it's where the line crosses the y-axis. So in order to graph this, I'm going to go ahead and plot the y-intercept first. So the y-intercept is 3, which means that's where the line crosses the y-axis. Now since the slope is negative 1/2, that means I need to go in the negative direction for one of my values, either x or y. So if I go down 1 unit, then I'm going to go to the right, which is the positive direction for the x values, 2 units. So remember, rise over run. So y values on the top, x values on the bottom. So go down 1 y value and to the right 2 x values. The other way that you can think of it is going positive in the y values and negative in the x values. So I could also go up 1 and then to the left 2. Notice that these 3 points are all in a row, which should make sense if the graph is supposed to be a straight line. Quick question for you, how would I find the x-intercept for this line? Remember that we talked about you have to plug in 0 for x to get the y-intercept. You would have to plug in 0 for y to get the x-intercept. If I really wanted to know the x-intercept for this equation, I would plug in 0 for y, so I'd have 0 equals negative 1/2 x plus 3. I would have to solve for x, so subtract 3 from both sides. So I'd have negative 3 equals negative 1/2 x, and then in order to get x by itself, divide by negative 1/2, which is the same as multiplying by its reciprocal. So I'm going to multiply by negative 2 over 1 so that the 2's cancel and the 1's cancel, and a negative times a negative is positive. So then I have to multiply negative 2 over 1 on the other side. So we end up with negative 2 over 1 times negative 3, so we end up with a positive 6 is my x-intercept. So remember, that means I had a 6 for the x value and a 0 for the y value. So there's the x-intercept. Let's say that instead you're asked to graph the line that goes through the point negative 4, 1 and has a slope of 3. You're going to go ahead and plot your point first. So since it's negative 4, 1, you're going to go to the left 4 units and then up 1. And then your slope is 3, which is the same as 3 over 1. So that means your y values are going up by 3 and your x values are going to the right by 1. So we need to go up 1, 2, 3. I did not space those out evenly. And then you go up 3 more and over 1 more. And then we'd have 3 points for our line. I actually want to point out here that with the previous line that I drew, it goes down from the left to the right and the slope was negative. With the one that I just drew, it goes up from the left to the right. So if you're reading the graph from the left to the right, it goes up, and the slope here was positive. So keep that in mind. So in this section, we actually also look at the idea of parallel, perpendicular, and neither. Parallel lines are lines that run next to each other forever but never touch. They have the same slope. Perpendicular lines are lines that cross at a 90-degree angle or at a right angle. Their slopes are opposite reciprocals. Opposite reciprocals means you change the sign, so if it was positive, you change it to negative. If it was negative, you change it to positive. That's the opposite part of it. Reciprocals means you take the fraction and you flip it. You make the numerator the denominator and the denominator the numerator. So if you were actually to multiply perpendicular slopes together, you'd get -1. Now, there are some lines that are neither. So you can have two lines that are not parallel and they're not perpendicular. So something like this, right? They're not running next to each other forever and they don't cross at a right angle. So that is a third possibility there. But two lines always have to be one of those possibilities: parallel, perpendicular, or neither. Keeping that in mind, consider the following problems. Determine whether the line through the points 1, 5, and 2, 7 and the line through the points 2, 10, -6, 14 are parallel, perpendicular, or neither. So we're going to have to find the slope for both of those lines. So for line 1, the slope is equal to, and for line 2, the slope is equal to. Oops. For line 2, we remember y2 minus y1, so 7 minus 5 over x2 minus x1, so 2 minus 1. So we end up with 2 over 1. So the slope for line 1 is just 2. And for line 2, we would have y2, which is 14, minus y1, which is 10, over -6 minus 2. So that ends up being 4 over -8, which simplifies to be -1/2. So these 2 and -1/2, they're opposite sign and they're reciprocals, because if you take this 2 over 1 and flip it, you get 1/2. So they're opposite reciprocals, which makes these perpendicular lines. Okay, second situation here, determine whether the lines are with equations y equals 5x plus 3 and -3x plus 5 are parallel, perpendicular, or neither. These are actually in slope y-intercept form. So the slope of the first line is 5, and the slope of the second line is -3. Those are not the same, and they're not opposite reciprocals. So these lines are neither parallel nor perpendicular. So then when we look at the last example, it says determine whether the lines with the equations 8x minus 4y equals 12 and 2x plus 10y equals y, oops, it was supposed to say are parallel, perpendicular, or neither. I'm going to work with the second one because it's a little bit easier, because if I just put y equals 2x plus 10, which means the same thing, I know the slope is 2. With the second one I have, or the first line I guess, I have a little bit more work. I have 8x minus 4y equals 12. If I subtract 8x from both sides, I have -4y equals -8x plus 12. And I would divide both sides by -4. Remember, divide everything. And I have y equals a positive 2x plus, this actually is minus because you end up with a negative 12 over 4, which you can divide the top and the bottom by 4, so you end up with a -3. So the slope of this line is actually also 2, which means that these are parallel lines. So with that, I'm out of time for this video, so I will stop here. Remember with word problems that you are looking for the rate of change when you're looking for the slope. So if you see rate, be thinking slope. So with that, I will end this one here. Bye!